I'm Michal Hrusecky. I'm from CZ.NIC, where I work on a project called Turris. And one thing that we do is Turris Sentinel. I will talk about what we do in detail. We are part of CZ.NIC. We are developing Turris routers. They are really cool. We have plenty of resources, open source. And yeah, stuff that you might like DNSSEC, root accounts, and some security features. We have actually three main security features. Two of them are for monitoring the local network. We are monitoring stuff internally. We have a thing that we call PACON, which is basically NetFlow monitoring, and it also uses data from DNS requests and TLS handshakes, so we can collect domain names for the net flows. And we are starting to experiment with IDS, basically trying to deploy IDS on routers of normal people and get them some notification from IDS. But the thing that I'm going to talk most about today is something called Turris Sentinel. And that's basically something similar to what previous speaker talked about. We are also making a gray list of evil people on the internet. And we have also dynamic firewall. So how our Turris Sentinel works. We have a set of minipods. I will tell you which. We have we call them minipods because they are minimal honeypots. They are not full honeypots because honeypots have quite some complexity. And if you are doing something complex, it's easy to make an error, mistake, some bug, and then you got from honeypot to possible vulnerability really easy. So we do minimal honeypots for protocols that are listed there: FTP, SMTP, HTTP, and Telnet. They follow the protocol structure. We ask the potential attacker to log in to our services. And if he tries to, we collect the credentials because those might be interesting, and then we kick him out, because we don't want to simulate any extended behavior that could prove to be problematic and dangerous. And apart from that, we are also collecting firewall logs. How it works: we collect all those data, send it to our infrastructure on our servers. There we do some basic filtering, make sure that it comes really from our routers, that it is correctly signed, that it came over encrypted connection. We do some other filtering and some various forms of analysis, and we also have a scoreboard. We also score the addresses, and then we publish the resulting firewall rules. And we also have one external source of information, and that is Honeypot as a service. That's another thing that is already run by CZ.NIC. And that's something that you can easily install even on your own server. And basically, it's a service where CZ.NIC runs Honeypot, and you run man-in-the-middle proxy on your server and forward attackers to CZ.NIC honeypots. And you get nice visualization. And if there is an error in the honeypot, you don't care because it's CZ.NIC servers, not yours. And we collect those data as well and use them to find the bad guys. So our requirements for doing this is we need to be able to react quickly. As mentioned, it's really crucial to be able to adapt fast. And also, we need to remove people from our gray list when they start to behave, because there's there's not a lot of IPv4s, so people are sharing them. They are moving between IPv4s and stuff like that. And one thing that we need to extremely protect ourselves from, and that's actually kind of tricky when moving away from our routers, is that we have to make sure that it's not easy to trick us to enlist somebody really fast. So one router can't bring you to the gray list. We have to have reports about a bad guy from different routers and with different actions and stuff like that. So that's the part that is constantly evolving is how we evaluate the stuff on the server. We are continuously trying to improve that. And yeah, therefore, data processing and scoring is done on our server. So we can easily change the algorithm, easily tweak it. When we find some false positives, it's easy to add whitelist, add IP addresses to the whitelist. One thing that was really tricky when we were dealing with is, for example, Let's Encrypt. Everybody uses that. And Let's Encrypt uses various servers around the world to check that you are actually the owner of the website and they are doing requests from various IP addresses and making sure that the authorization token is there. And because they are trying to make it hard for attackers to steal that traffic, it's also hard for us to distinguish that those IP addresses are good because they are from all over the world and there is no fixed list. So we added some possibility to whitelist based on the requests. So we are recognizing the Let's Encrypt authentication request and whitelisting those. So data processing is done on our server. Dynamic firewall publishes full list of IP addresses and also the difference because we actually have 2 channels on our dynamic firewall. When it started, it listens for the full list of IP addresses and then it listens just for the difference, so we don't have to download everything all the time, and all the processing is done in real time. So whenever we get new information on our servers and it triggers the update of the firewall, it triggers the update of the score big enough to add the attacker to the firewall, it will get published in real time. We don't have to wait for anything and stuff like that. Now, we have this system running for several years. I think we are close to 10 now, but we were running it only on our routers. One thing that, one motivation is that it's hard to figure out how to do it without knowing the source of the data. But we decided because, as I mentioned, we are using Honeypot as a service as one of sources of our data. We found out that it's really popular and people would like to contribute and run honeypots and help others be protected from the bad guys and also trigger bad guys a little. So we are working on making it available outside of our routers in general public. Dynamic firewall is really easy. We have a client, it can listen, it can maintain IP set. We made some firewall-D and systemd integrations, so it's really easy to deploy that part. There is no danger to us and to our network from that. Sending the data is much harder because we want to avoid people registering 1,000 times and with 500 registration from Australia, 500 from US, 500 from somewhere else, and trying to pretend that there is a new attacker, which is their biggest competitor, and trying to get him on the list and do some nasty stuff. So we have to somehow trust our resources. And to be able to deploy everything easily, we need to package everything so it will be readily available in various distributions so people can actually deploy it easily once we figure out how to get them on board. So one technology that we use to solve one of those problems is Open Build Service. There's actually a nice feature that if you talk to OpenSUSE guys, they will create a nice project for you. And we asked them for Security Sentinel, and we put there all the packages that are needed to run our minipods and to use the dynamic firewall. It's a one repository, one source repository where you can put your sources, all the recipes, and it will build your packages for various distributions like Fedora, OpenSUSE, SLE, Debian, Ubuntu. And it has a nice feature that you can write source services, and it will fetch your sources directly from your public GitHub and start building them and change the release number in all the packages. So with one simple command, you can update all the packages. It will take dependencies, rebuild whatever is necessary. So that solves one of the problem, the technical one. That is, yeah, that's it's easy to solve technical problems. There are tools for that. The harder problem is to figure out how to identify people, because what we do currently is every our router has its own serial number, and it has some key that is available on every router. On Turris Omnia, there is some symmetric cryptography. We have a copy of the key, and we can verify if some secret was signed by Omnia correctly. For Turris mocks, we have elliptic curves, and we have private key is generated directly in OTP in factory, and we have only copy of the public key. So we can again verify that data that we are getting are signed by this particular device, that it's this serial number and corresponding key. So we can trust that it's data coming from that device. For people, it's much harder. Our approach to solving that is we will pretend that everybody is a router. And basically, we can generate fake serial numbers for everybody. That's fine. The harder part is key. But since Turris mocks, we have the asymmetric cryptography, so we can use, again, elliptic curves, let people keep their private key and send us just the public key. And technically, we solved it. The tricky part is how to make sure that nobody generates hundreds of accounts. So first step that we are starting with is some B2B cooperation. I will be honest, we still don't have it running anywhere else apart from routers and few developers. But we have in progress proof of concept with one of ISPs that we are working together to deploy it on their network. And why we are targeting businesses in first step is because it's there's not that many of them, so it will be less communication. And with everybody that we will get much more information than from private people. We will get more reports, we will protect more people. In case of ISP, if they deploy it in their own network, they probably have plenty of IP addresses that they don't use currently, and they have in stock for business customers. And at the same time, the reputation database will help them to protect much more people than if we dealt with individuals. So we are currently working on this proof of concept, but since you are quite some of you are the ISPs as well, so if you are interested, maybe contact us, and the next proof of concept can be with you. We want to do the same thing with end users, but it will be much harder because there is many more of those. So we would have to make this more automatic because of the wider audience, and we will also have to figure out a way how to distinguish individuals, because everybody can have hundreds of emails and write hundreds of emails. So we don't know how to solve this yet, but our current approach, our current way of thinking is using some well-established identities like MoeID or CA-cert, and we hope that with help of those we will be able to push these servers outside to everybody, and everybody could help us collect data about the bad guys. Some last point information. If you want to know something about us, look at Turris.cz. One more interesting part is view sentinel.turris.cz. That's actually a visualization of the data that we collect. It's before filtering and before all the scoring. So it's raw data. So there might be private IP addresses and stuff like that. But you can also see popular passwords and popular logins. So you can check whether you picked your password well, and it's in top 10 used passwords by attackers. And if you have some more questions after the conference, or if you want to be next business that we will do proof of concept with, drop me an email and let's talk.
So is there already a question?
Maybe the first one. Tom Kostner.
Yeah.
Simple question, as in previous presentation. Do you support IPv6?
Yeah, great question. And yeah. Yes, but well, all the components are kind of ready for that, but we don't do it yet. The answer is because we are currently running it on the routers of the people that are running it at home. And this is actually a rewrite of the previous program that we had a long time in the past. And since we are running it on home routers, we found out in a previous program that there is not much attacks on IPv6, because basically IPv4 you can scan really fast. There's just few IP addresses, and if you are not running any services, you get exposed and you get attacked even on IPv4. If you are using IPv6, that's something that you cannot scan automatically, so you have to give out your IP address to the attackers somehow. So that's our theory why we got much less attacks on IPv6. But with going to ISPs and other businesses, we will have to start using it as well. But yeah, everything should be almost technically ready, and there are just few pieces that needs to be put in place, and we are planning to do that.
I want to give a little remark. Some time ago, I installed an IPv6 address with my operator, and in maybe 2 minutes, I got an SSH scan on that address.
Okay. So maybe times are changing. Yeah, as I said, we plan to support it, and we are working on it. We just didn't deploy it yet because from our previous experience, it wasn't as important in home users scenario.
There are 2 questions on Slido. So the first question is whether you use the gray list in front of your infrastructure, like DLD, DNS servers, and so on.
It's actually 2 questions at once, because, but I think the answer is the same for the both. Well, we don't use it in front of our infrastructure. Mainly because if we mess up and break it, then we still need our routers to connect to us and fix it on them. So if we would put it in front of our repositories and release the update that will break it, then yeah, it's better to protect somebody else so you can fix it when you mess it up. And if I believe that millions of users will join, and whether it is not sufficient to use personal contact to obtain credentials, I don't know if millions of users will join, but I believe that thousands will join for sure. And the tricky part with personal contact information, like stuff that you have on your ID, like your first name and last name, that's easy to have thousands of them unless you verify them somehow, like using my ID or something else. If you are speaking about personal contact, like giving out vouchers on conferences, yeah, that sounds like a great way to do that. And that's actually how CRZ does it. And they've been doing that for, I don't know, maybe 10 years as well. So I think it might be best to collaborate on that part and work together to get as much people that we can. And yeah, we cannot be on every conference around the world, but there is always somebody that knows somebody. So that's easy to use other people's networks to verify people.
Okay. I would like to ask a question on my own. Actually, I wanted to ask about the data processing part, because there was the huge diagram full of many boxes, but I can remember that the plan was to have somehow speedy streaming data-driven data processing system that would actually minimize the time from hitting the honeypot or minipot to actually generating the IP set and forwarding or distributing the IP set to routers or to customers. Yeah. And actually my question is whether it is a limitation for more sophisticated data science or machine learning methods, because the way I understand all these methods that I read about is essentially that they need some data set that is static at that point. They can work on it, cluster it, derive some matrices, or derive some, or learn from that data set and apply it to other data. But is it possible to actually implement anything of that, and do you have it?
Okay, so I will start with the response time and flexibility. Basically, all the data that we have are processed in the stream. So basically, when somebody connects to one of the routers, we get a message to our servers. When he enters credentials, we get another message. This message goes through some pipeline of processing where it might trigger another action. And if it triggers scoring in a way that it goes over some threshold, it will trigger publication in dynamic firewall. And that dynamic firewall client is always connected and listen to the stream of events. And it will get the change in the firewall, the message about the change in the firewall, as soon as possible. So basically, once you trigger an event, it will get to the firewall as soon as it gets to our servers. So I would say seconds at most. Regarding the processing and analysis question, we do have, well, one thing that we did when we started with the project was to make it really easy to split the processing of the data between multiple servers. Tricky part with these smart algorithms for analysis is that you usually have to have a huge data set, as you said, in some cache. We have some Redis somewhere deployed, and we have some other local caches that we are using on the way. So some of those boxes actually maintain some temporary state in between. But so far, we are managing to fit on one server with everything. But over the time, when those millions of users, as mentioned in the question, will join, I'm afraid that we will have to somehow split the data into multiple servers for all those algorithms. And we are constantly working on improving those algorithms. And yeah.
Okay, thanks. Are there any other questions? Okay, so thank you very much.
Thank you.